correlation technique is model based reasoning. An event correlation based model based reasoning is built on object oriented model associated with each managed object. A model is a representation of a component. It models the traditional object oriented representation, has attribute relocation to the other model, and behavior. The relationship between the object is reflected in a similar relationship between model. Looking at the figure, model based reasoning event correlator, where it consists of NMS or correlator component, backbone network, router, and the router in turn consists of three hubs: hub 1, hub 2, hub 3. This is nothing but physical network. Looking into the figure B, equivalent model, the router model is connected to the hub 1 model, hub 2 model, and hub 3 models. Let us picture a network of hubs that are connected to a router shown in figure A. The NMS pings every hub and the router periodically to check whether each component is working. We can associate communication between NMS and managed component as between the model in the NMS or the correlator and its counterpart of managed object. Thus, in this example, the model of each hub periodically pings its hub and model of the router pings the router. As long as all the components are working, no additional operation is needed. If hub 1 fails, it is recognized by H1 model. Let us assume that H1 model is programmed to wait for lack of response in the 3 consecutive pings. After 3 pings with no response, the H1 model suspects a failure of hub 1. However, before it declares a failure and display an alarm, it analyzes its relation to other models and recognize that it should query the router model. If the router model responds that the router is working, only then the hub 1 alarm is triggered. If the router model responds that it is not recognizing a response from the router, then the hub 1 model deduces that the problem is with the router and not hub 1. At least it cannot definitely determine a hub 1 failure as long as it cannot communicate with hub 1 because of the router failure. Looking to the third one, the correlation technique is case-based reasoning. It is called CBR. It overcomes the many of the deficiency of RBR, that is rule-based reasoning. In RBR, the unit of knowledge is rule, whereas in CBR, the unit of knowledge is case. The intuition of CBR is that the situation repeat themselves in the real world, and that what was done in one situation is applicable to other in similar but not necessarily identical situation. Thus, when we try to resolve a trouble, we start with a case that we have experienced before. Looking at the figure of a general CBR architecture, where it consists of 5 components: the input, retrieve, case library, adopt, and process. The general CBR architecture is shown consists of 4 models: input, retrieve, adopt, and process, along with the case library. The CBR approach uses the knowledge gained before and extend it to the current situation. The former episode are stored in a case library if the current situation as received by the input module matches one that is present in the case library. That is, as compared by the retrieval model, it is applied. If it does not, the closure situation is chosen by the adopt module and adapt to the current episode to resolve the problem. This process module takes the appropriate actions once the problem is resolved. The newly adopted case is added to the case library.